Good morning everyone. My name is Annu Rani, Department of Machinery and Power Engineering, College of Technology, Panagar. My topic is that a study on agriculture desk, wear behavior under condition of a different soil. The concept of my research is that means we can see that in agriculture machinery there are lots of problems. First problem is that a wear, and second is corrosive. But I choose for my research abrasive wear in agriculture machinery. Means uh, basically in a farmer they face a lot of problem in agriculture machinery because of wear, but they don't know what is the life of a particular agriculture machinery and how to choose a proper machinery for according to their life, according to their cost, and how to take sufficient stock in advance. So that is the main issue for farmers. So firstly, abrasive wear of a tillage tool is a major problem for farmers all over the world. The hard mineral particle of a different soil can cause several wear and damage in working machine elements. And as the annual use of a disc harrow is increased day by day due to increasing cropping intensity and wear of its critical component, namely disc, also comes in the picture. As we know, disc is a primary and secondary tillage implement. Disc harrow is the primary and secondary tillage implement. The purpose of disc harrow is that it cuts the soil and pulverize the soil. And in Uttarakhand, most of the farmers they use disc harrow. Hmm? There are different types of disc harrow in market, and there are different types of different make of disc in market according to their weight and according to their hardness. And in a disc harrow, the wear is reduced outer dia and blunting of a cutting edge, as well as change the surface lead to increase the fuel and lubricant consumption. Wear lead to addition cost in terms of replacement cost and replacement time. The expected outcome of my research is that keeping the adequate inventory and minimize the downtime, minimize the cost of replacement, and reducing the effect of wear on a timeline of operation. I choose three objectives from my thesis. First objective is that to determine the wear of a various makes of discs in a circular soil bin using different soil and operating condition. Secondly, to assess the wear of a disc in actual field condition and its comparison with the result of soil bin test. Third objective is that to establish mathematical relation between the result of soil bin and actual field condition test. This is the methodology for this experiment. This experiment plan for circular soil bin in an independent parameter. I choose make of disc 4 level, that is local double canter, tiger and hippo, and secondly types of soil, that is sand and silty clay loam soil 2 level. In a moisture contained sand 0 to 2% and 6 to 8%, and for silty clay loam 6 to 8 and 12 to 14%, that is 2 level. And speed of operation of a circular soil bin is that 2.5, 3.5 and 4.5 km per hour. Dependent parameter are weight reduction in gram, radius reduction in mm, thickness reduction in mm. And I choose four fixed parameter: depth of operation 10 cm and diameter of a disc is 24 inches. Total number of experiment for a circular soil bin is 48. Experimental plan for field test. In field test, I choose in an independent parameter make of disc, local double gander, tiger and hippo, and dependent parameter weight reduction in gram, radius reduction in mm, thickness reduction in mm. Fixed parameter depth of operation 10 cm, diameter of disc is 24 inches, speed of operation 4.5 km per hour, types of soil silty clay loam soil. Hmm? This table shows the specification of a disc used for this study. Make of disc, I consider M1 for local one, M2 for double Ganta, M3 for tiger, M4 for hippo, and cost of disc is for M1 810, for M2 900, for M3 1015, and for M4 1100 rupees. Material of a construction of a disc is high carbon steel EN42. Average diameter of disc 610 mm. Average thickness of disc is 4 mm. Bevel angle double bevel 60 by 30. Concavity 90.07. Diameter of key hole is 65 mm. Key size 15 into 50. This is the section view of a disc. Section view of a making on a disc. Making on a disc. This table shows the hardness and material composition of disc. Uh, I choose disc and I analyze the SAM analysis in veterinary department in Pandnagar. Okay, and I found that maximum hardness for M4 make of disc and minimum for M1 make of disc, and I found my maximum carbon content in M1 and minimum carbon content in M1 make of disc. And after that I analyze the data through full, fact, full factorial design and develop the development of a prediction model. Okay, in experiment I choose full factorial design. After that regression analysis for 100-hour test using this model, and then analyze through ANOVA using many software, and the wear rate value were predicted by the quadratic equation and compared with the fair result. And then the prediction equation was modified by the multiplication with factor. After that, the values predicted by modified equation was compared with the result of field test and tested by goodness of fit analysis. After that, optimization was carried out using the multi-level category design in a general full factorial design using design expert software. This is the result discussion. I plot 3D surface uh, 3D surface plot for gravimetric wear and dimensional wear. In gravimetric wear, weight loss; in dimensional wear, radius and thickness reduction in sand. You can see in this graph, when we increase the hardness and time, wear also increases. Same as when we increase the moisture content and speed, wear also increases. This is because of the hard particle of a sand. This table shows the percentage increase in a wear due to moisture content, speed and hardness. You can see in this figure means weight loss from 0 to 2 to 6 to 8%, 148.72%, radius reduction 7.56%, thickness reduction A to H 97.66 to 80.98%. Speed went 2.5 to 4.5 km per hour, 10.063%, radius reduction 8.85%, thickness reduction 12.37 to 7.42%, and hardness from M4 to M1 45.45%, for radius reduction to 55.56%, thickness reduction A to H is 30.83 to 39.16. And this surface plot diagram in a silty clay loam soil. In this diagram, when we increase hardness time, then wear also increases. But what happened in this, when we increase moisture content and speed, when we increase moisture content, then wear decreases. This is because of bulk density of a soil and pond index of a soil. And when we increase the speed in kilometer per hour, wear also increases. This table shows the percentage increase in a wear due to moisture content, speed and hardness in silty clay loam soil. And this plot for in a this plot in a field condition. When we increase hardness and time, wear also increases. This is the model analysis. Okay, for all models are adequate for weight loss, radius reduction and thickness reduction. These are half normal plot of a wear in general full factorial experiment. In this graph, you can see the maximum effect on a wear is time, after that hardness, then moisture content, and lastly speed. And this is the summary and conclusion of my research. The first conclusion is that the effect of soil parameter, tool parameter, and operating parameter on a grammetric wear and dimensional wear of agriculture, this was found sufficient significant. In a field condition, the cumulative wear was 3.49, 1.79, and 2.27 times more than the laboratory condition in terms weight, radius, and thickness loss for this M4 respectively. The wear life of a disc having of M1, M2, M3, and M4 was calculated as 423.86, 58.51, 950.64, and 1329.14 are respectively. The life of a disc M4 was 3.14 times more than the life of this M1. Thank you so much.